up here. So we're just gonna start at C. C was the one that was supposed to begin. Alright? So we did that part already. And he said the cash price of a laptop is $1,299. It can be bought on hire purchase by making a deposit of $350 and 10 monthly payments of $120 each. And the first thing they want to do is what is the total hire purchase price? Now, total hire purchase is equal to the deposit plus the total monthly installment. So if you make a 350, that's the first money where you pay down, right? And then now you're gonna pay for 10 months, 120 each. So that is a fixed amount where you pay. So it will be 120 times 10 months. So that gives you a total of 1,200. And then all you do is just add the 350 to it to get the total, which comes to 1,550. So this will be the answer for this one. A very nice 2 marks, that guys. Alright, them say now, how much you save by buying the laptop? Cash. So all we need is the difference of the total hire purchase, which is this, and the cash price. Because if you pay cash, that's it, right? Yeah. Like what them do, they never put no heap of tax on where you have to calculate. So it's pretty straightforward. Alright, so we're gonna subtract because it's the difference. 9 from that we can't. Borrow 1 here, so 9 from 10 leave 1. 9 from 4 we can't, so we have to borrow 1 again. That leave 4. 9 from that leave 5. And 2 from 4, 2. 1 from 1 is 0, so that's $251. So the customer would save $251 if them buy it cash. Always better if you buy it cash, guys. Always better. Alright, it's a one vector. It says in the diagram below, not drawn to scale, P and Q are midpoints of OA and AB respectively. OA is equal to 2A and OB. Well, I could do this in a class right? Still do it, guys. Express in terms of A and B. Express in terms of A and B, the vector AB and the vector PQ. So I'm going to go back home. I'm going to make it a little bit smaller so you guys can see the reading. What go on this one? Oh. Yeah, guys. So you can read it. And then them ask you to find two things, AB and PQ. I'm pause the video so now I'm going to blank space. Alright, so say, oh, I missed the heading. Go back up right there. It's in the diagram not drawn to scale, P and Q are midpoints of OA and OB respectively. OA, let me just put in that. OA is equal to 2A. So you know them, the direction matters, yeah. And OB, so from O to B equal to B. And they ask us to find from A to B. So we're literally going from here to here. So in this case, they say this is 2A, right? So all we do, we're going against the arrow. So this would be minus 2A. Now, I'm going to do it, so guys. Let me write it out for the persons who are not seeing it as well. So we're going from A to B. Alright, we're going from A to B. Alright, this now would be from A to O. So we go from A to O, that's our starting point, plus from O to B. So OA, no, AO is the opposite of OA, so we have to stick out the negative, right? So that's negative 2A, because we're going against the arrow. But with this one, we're going with the arrow, so it will be plus 2B. And we know, so we normally turn it around, so it will be 2B minus 2A. If you want, you can factor out the 2, and then it will become B minus A. So that would be AB. And then now, it's a go from P to Q. We assume, say, since we know AB, could we just divide it by 2? Because that's what I was thinking in Jaden. But I could do it the way you did it as well. Since we know from A to B, we know this is 2B minus A. And since Q is the midpoint, oh, but they want from P to Q. I keep thinking that. Yeah, it's from P to Q.
That's
Yeah,
yes.
yeah, yeah. We keep thinking of from A to Q, you know. No, it's not that. Alright, so it's actually from P, which is here, to Q. Alright, so from P to Q, look, see. We're gonna go PA first, and then AQ. So from P to A, alright, since this is 2A, and this is the midpoint, it means that this is A, right? So this would be A. From here to here, it would be A. Agree? Because remember, we start in, all of it is 2A, but this is the midpoint. So P is the midpoint, so if it will be half. So if this is 4, this is 2. If this is 10, this is 5. So it's a half, so it will be A plus AQ now. From A to Q, we're actually going with the arrow, right? Because that's AB. So all we have to do, find a half of this. So that'll be plus 2B minus A. Now we just divide by 2. That will work out to B minus A, right? So it would be A plus B minus A. So this is going to work out to just B alone, you know. So A minus A plus, which this cancel this. So from P to Q is just B alone. Makes sense, right? See 2B here and see B here. I remember about this. This is okay. I don't want this as 2A, B, C. So either side of A and either side of A. Alright, it says state two geometrical relationship that exists between OB and P. Then basically parallel. You can't think of a next one. And one is a multiple of the other. No, I don't see no the other relationship. Just parallel. We need to find out why the other relationship between them two lines. Now, let me get back to that one there, guys. I'm going to lose a mark there. Alright, it said given that m is equal to 2, 1, 4, 3, evaluate the inverse of m show that m, the inverse of m times m equal I, which is the identity, right? And it's a use the matrix method to solve for R, S, T, and U in the equation. Alright, so what's up that, guys? That one you take a little while, 2, 4, at a 9 marks. This should have take up some time, I guess. Alright, so given that m is equal to 2, 1, 4, 3, evaluate the inverse of m. So let me just rewrite this. The inverse, first you have to find the determinant. So you have to find the determinant first. And the determinant will be AD minus BC. So it'll be 2 times 3 minus 1 times 4. So 2, 3, 6 minus 4, and that's equal to 2. Alright, so we have 1 over 2. We need the adjoint now, right? So 3, I go up with 2 there, and 2 over stop with 3. And then for B and C, we change it. And that will be the inverse. And you get 2 marks, right? Alright, them say show that the inverse times m equal this. So we already get this guy, so we don't have to worry about this again. That may like both sides. Sometimes they make it a little bit. Now times that by 2, 1, 4, 3. Alright, can't write fast, let's up. Alright, so we just gonna say a row by column. So 3, 2, 6. Negative 1 times 4 minus 4. After the row 1, column 1. Now we have 3 times 1, positive 3. Negative 1 times 3 minus 3. And you continue now, but you continue with row 2. So that will be negative 4 times 2, that's negative 8. Positive 2 times 4, positive 8. And then negative 4 times 1, negative 4. 2 times 3, 6. Yeah, but 1 over 2. 6 minus 4, that's a 2. 3 take away 0, 3, 0. This is 0. And then this work out to 2. But remember, we're supposed to divide by this, right? So I divide 2 by 2. So 2 into 2, 1. 2 into 0. 0 times, 0 times, and 2 into 2, 1. So these are the identity. And would I get 4 marks for that now? Now that one here say,
Yeah, I said that one here.
yeah, that me realize. It say use the matrix method to solve for R, S, T, and U. So basically, guys, you can see that it's an equal matrix, right? Let's see if we can figure it out. So once I see it like this, 2, 1, 4, 3, it would be row by column, technically, as a multiply, right? But this must be in rows, and then they must be in columns. So although our letters, they just multiply it out same way, and then we equate it to this. 2 times R, 2R, 1 times T, positive T, and this must equal to 2. No, maybe not this one. Not yet, guys, because I don't want to confuse persons. I'm going to write it out first. I'm going to multiply and then we equate. Alright, because I don't want persons to start saying. So 2 times S, that's 2S. 1 times U, U. 4, 3 now, 4 times R, 4R. 3 times T, 3T. 4 times s, 4s, 3 times the SL, like 4 times s, 4s plus 3 times u, 3u. So I could equate it to them here now, which is 2, 1, 4, negative 1. So guys, you can see say is a basically you can get some simultaneous equation, right? Who recognize that? Because look, you have this 4r plus t, 4r plus that. So we could find the value of, we could solve with r and t. Alright, so I'm going to get rid of the t, so I'm going to multiply by 3 and 1. I think we can know what r, you know. I think r are 1, and the next one is 0. I'm going to work it out. Because look, 4 1's 4, plus 0, 4, and 2 plus that. Yeah, I think of that. That's for sure, we could work it out. So we have this times 3, and this times 1. 3 times 6, 3 times 2, 6r, 3 times that, 3t, 3 times 2, 6. Multiply by 1 now, 1 times 4r, 4r, 1 times 3t, 3t. Do you know that number? Hello? Hello? And 1 times 4, 4, right? So now with a subtract. So 6 take away 4, that's 2r. 3 take away this, that is 0. And then 6 take away 4, 2. So as I was saying, I think r are 1. See there? Work out to 1. So once r are 1, we can say 2 times 1 are 2, right? And if it equal 2, that means that t must be 0. So t is 0. Everybody agree? Because only 0 plus a number can give about the same number. I'm going to try to figure out the s and 2s and so. So 2s, 4s, so plus u, so plus 3u. Alright, so this one must equal to 1, positive 1, and this one must equal to negative 1. Can multiply by 3 and 1 again, or 1 and 2. We do 2 by 3 and 1. I mean, I get rid of the a. Alright, so 3 times that gives us 6s. 3 times a, 3a. 3 times 1, 3. And then 1 times 4s, that's 4s. 1 times 3a, 3a. And that's why we did it, right? And of course, 1 times negative 1, negative 1. This time, the two of them are positive, so we have to subtract. In order to get 3a if it be 0, we have to subtract. So 6. Oh, I same thing we do over this one. 6 minus that gives us 2s. This here minus. Now, this minus go here, so right? So it's going to be 3 minus minus 1. So 2s equal to 4. Because this is going to become plus 3 plus 1, 4. So that means the s work out to 2.
Sure. Quick question, sir. This
Come on.
would be considered as a matrix method.
Hmm?
This would be considered as a matrix method.
Well, I would say yeah, because we expand the bracket. Although this come like a regular way we are the box same way. If we were to do it, the matrix method, like, we'd have to rewrite it again.
Yeah, let me check it out. I never really know what to do. So I just did skip through a quick YouTube video. Then they say find inverse and them something. I still like the same answer so far though, so
Yeah.
you can continue.
Yeah,
But
we
you can
can do
check
it
it
that
out
way
from
that
my
you
saying
know.
you.
But by multiplying it, technically the matrix method they are use. But probably them one if we go back and find the inverse and then multiply row by column again. So it could be. So S equal to, I'm gonna ask me HOD if somebody do this if they not get the marks, because technically you'd have to multiply this row by column. So probably the one you have to repeat the process. If possible, we can do it that way that you know. So S equal to, but I think you lose the mark. So S equal to, and then we can put 2 in this, in a 2S plus U equal 1. We use that equation. So we have 2 times 2 plus U equal 1. So this is our 2 2s are 4 plus U equal 1. So with a transpose, right? So that be 1 minus 4 U equal -3. Not U. Yeah. Are you that would just fine? A. Right, U, but a for this. So A it'll work out to 1, -3. Was it no man, it was U. No matter still. A U. I think I made a mistake and put A as well. If we were to do it the other way, we'd have, so we come here, so for myself, yes sir. We'd have to find the determinant, which is 2 times 3, 6. And then, oh, we already find the inverse of us, right? So the inverse will be 1 over 2. Let me see how the other part is. 3 -1 -4 2. 3 -1 3 -1 3 -1, was it -4 and then 2? That's it. That was the inverse, right? Inverse, the way that it even be short, and let me see for that. Yeah, 2 there, so 3 and 2 swap. And then it work out to 2 and 4. I think this is the easier way. So I multiply by 2 and 4, and this equal x squared. So with a multiply row by column, right? But we don't find the value of x and y and not the letter then. So 326 and then 326 -1 times that minus 4 minus 2 times this, that will be one -8, 2 times 4 8. And also on x and y are the other letter them if we use. So this will work out to 2 and 0. Same thing. And I guess then we could substitute the values and solve for the other one then. It no matter, guys. I see same thing here. Because technically, when you multiply it out, that a matrix is here. Alright, up to the circle theorem now. It says the diagram below, not drawn to scale, shows a circle with center O. EBC is a tangent to the circle. OBA equal 40 and OBF 35, and I want you to find these. Let me small it up, guys. 4 of them they want to find. So that's about 7 marks. So all that 11 minutes we should try to complete it, right? So let's see if we can match up that one here. Well, see if we can finish all right in a 12 minutes, guys. That's the time CXC gonna give you technically. Alright, hold on, guys, hold on. I not even realize I'm in the mute myself now. Somebody asked for 1 moment. Hold on, let's go. Alright, guys. I think that's will be it. I think it's a very small angle, so yeah, I think that's possible. Alright, let's go. So it's a calculate given reason for your answer, the measure of EBF, BOA, AFB, and OAF. And this year, this was worth 7 marks. So a lot of students like to fret about circle theorem and so forth. But if you guys notice lately, they don't carry a lot of marks. They just put a little matrices, a little this, little that. So, alright. So it says EBF. So it's E, B, F. Let me not see F. Oh, this is E, this is B, this is F. Says this angle they want, right? Now this is a radii. This one is also a radii. I see it angle at the center to the circumference. So the angle between the radii and tangent equal to 90 degrees. So all of this are 90. So it would be 90 take away the 35. As part of it at 35, which work out to 55 degrees. I get a reason, which is the tangent, angle between tangent and radii. So that's a between angle and right. Alright, next one is BOA. Look at the angle. BOA. So they want this angle right here. As I was saying, guys, we can see some isosceles triangle. So that means this side is equal to this. Right? These angles are equal, so this will be 40. So it will be, we'll call that one here B, like for BOA. So B plus 40 must give you 180. So this will be B plus 80 equal 180, and we do the transpose. Subtract 80 from both sides. So B equal to 100. So this BOA here work out to 100. And we know the reason angles in a triangle add up to 180. We try that. So 180. Alright, cool. Alright, now we have AFB. So we have AFB. So they want this angle right here. If we look at this, look at something we may mark out, guys. We have come I can be here, see existing to bring this. Let's focus on this one. Right? Angle at the center is twice angle at the circumference. Right? So that means if this is 100, that means this one would be 100 divided by 2. Or this is supposed to be half of it. So that would be 100 divided by 2, that's 50. And we can give them the reason. Angle at circumference. Is half angle at center. Alright, boom, that's a one. Alright, this is the one that give a little trouble, but eventually the persons figure it out. Guys, just consider the big triangle. That's the root I would take. So consider this big triangle right here. Right, this is 100. Something like that. This is this is a 50. As I was saying, yo, it's supposed to be 50. So this is 50 plus this plus the 40 plus the little piece here. It was 180. I'm going to figure it out. So this is supposed to be 50. Remember, angles in a triangle add up to 180, right? So we add the 35 plus the 40 plus the 50. Them three here I'm adding up. This and this. Plus another 40 and a little piece. So we could call a little piece F. All of that give me 180. And then we add this. 40 and 40, 80. 80 plus 50, 130. 130 plus that, 165. So the piece will leave, that will be the value. So that will be 180 minus 165. 5 from that, 15. So this is equal to 15. And we can say angles in a triangle sum up to 180 again. Guys, just stop here for tonight. Angles in triangle sum 180. But you define it literally. Alright, so guys, we're going to end for tonight. The 10 minutes now kill us. We have accounts are the best, we have other subjects are the best.
What we're ending for tonight, sir?
Yeah, we are.
Oh, aren't you? Good night, sir.
Yeah, man, big up the John. Big up, guys. Take care.
Yes, sir.
Yes.
Good
Alright,
night,
big
sir.
up, guys. Have a stressful day. But I'll try sending a video tomorrow.
Okay, sir.
So at least we look at some vectors and we'll look at piece of circle theorem. Yeah. I have a lot more to do still. 11
Yes,
pages.
sir.
Alright. So take care, guys.
You too, sir.
Alright. Yeah, man. Thanks a lot. Thanks a lot.